basics of data transmission. Okay, so how the data is transmitted in a communication network, and what are the various types of transmission media. Okay, what is wired transmission media, what is wireless transmission media, what are the characteristics of wired transmission media, what are the various physical cables used for wired transmission media, and in unguided transmission, wireless transmission, what are the basic characteristics of wireless transmission media, and how antennas will play a role in converting signal from one form to another form. These are all the basic things we are going to discuss, some of the characteristics of data transmission in wired as well as in wireless medium. We are going to discuss. Guys, able to follow me? Hello? Hello?
Yes, sir. Yes, sir.
Okay, thank you. Okay, so we are going to discuss some of the basic terminologies in wireless transmission as well as in wired transmission, such as what is bandwidth, what is spectrum, how the signals are transmitted, in what form the signal has to be communicated. All those things we are going to discuss. Okay, so first, data transmission. Okay, data transmission is how you are going to transmit the data in some format. Okay, so the data, it can be analog data or digital data. It has to be converted into a form so that it can be transmitted over the transmission medium. Okay, so converting into electromagnetic signals, we need to convert the data into a format so that it can be transmitted over the transmission medium. Okay, and the how we are going to transmit the medium, it depends on that what type of medium we are going to use. Okay, and the medium can be guided medium. What is guided medium is, a guided medium will use physical cables such as twisted pair wire, and in twisted pair wires there are various categories like shielded twisted pair wire, okay, unshielded twisted pair wires, and optical fibers. These coaxial cables, these are all some of the guided medium by which signals can be transmitted. Okay, and what is unguided medium is wireless medium. Okay, air, water, these are all unguided medium. So in order to transmit the signal, the signal has to be converted into a format so that medium can accept and transmit it. Okay, so we need to convert into a format so that signals can be electromagnetic signals, because the medium can support only analog information. Okay, and so even if it is a digital signal, it has to be converted into a form so that the medium can transmit the signals. We are going to see some of the basic guided medium characteristics as well as the unguided medium characteristics. Okay, so before that, what is a spectrum? Okay, in communication, the spectrum is defined as the range of frequencies. Okay, if you have a signal, square wave signal, it will be composing of infinite number of sinusoidal signals, so it will have more frequency ranges contained in that. Okay, so that is called as spectrum. Spectrum is the range of frequencies. And what is bandwidth is? Bandwidth is the difference between highest frequency and the lowest frequency. For example, if bandwidth of a communication system, if they say it is 100 kilohertz, meaning 100 minus 0, so 100 kilohertz is the maximum frequency and 0 is the minimum frequency. The difference in highest frequency and the lowest frequency is called as the bandwidth. Okay, so the difference between the spectrum and bandwidth is, the spectrum is nothing but the range of frequencies contained in that particular signal, and bandwidth is high frequency, highest frequency minus the lowest frequency. These are some of the basic terminologies which are used in data transmission. If the bandwidth is very high, we will be able to transmit more information. If the bandwidth is less, we cannot transmit more information. It is limited to only few information only. The data is restricted. Okay, and it has direct relationship with the speed that the data is also transmitted, which is called as the data rate also. Okay, so data rate, coming to boys, are you following me? Hello?
Yes, sir.
Okay. See, bandwidth and data, they have one-on-one relationship. Okay. See, if they say bandwidth is high, it can support high data rate. Okay. For example, optical fibers, they have high bandwidth, and so it can support high data in the range of megabits per second or even gigabits per second also. For example, when you take a square wave will have infinite bandwidth. because it will have more number of sinusoidal frequencies will be there. It will have some of sine, cosine as well as sinusoidal waves. Okay, the square wave cannot be transmitted over a medium due to physical restrictions. That is why in form that it can be transmitted over the physical medium. Okay, Fourier series helps to analyze the waveforms. Okay, so when you analyze a square wave, it is square wave consists of infinite number of sinusoidal waves as well as cosine waves also. Okay, so when it has more terms in the mathematical equation, you can say it has more frequencies. Okay, that is why it is able to have the square-like shape. Okay, so when you have more bandwidth, then less distortions. The attenuation will be less, signal can be transmitted without any error. Okay, if the bandwidth is less, then it will have the signal transmission will have more errors and more distortion. But we have to pay money for the bandwidth. Okay, accordingly, if you have more bandwidth, the cost involved also will be more. The bandwidth is less, the cost it will be cost effective. Okay, so data and the high bandwidth, that is optical fibers. If they have high bandwidth, they will have bandwidth in the range of terahertz, and so they are able to communicate signals at their only that. Multiplexing is also possible. What is multiplexing? Is multiplex the ability to combine many signals over the same communication channel. That is multiplexing. So audio video data can be combined and they can be transferred over a common communication channel. Okay, that is called as multiplexing. And there are various types of multiplexing, like frequency division multiplexing, time division multiplexing, statistical division multiplexing. See, accordingly, the signals in time division multiplexing, time slots will be allocated for various signals and they can be transmitted. In frequency division multiplexing, large bandwidth signal will be divided into frequency slots and signals will be transmitted over this small frequency slots. Okay, so that is called as frequency division multiplexing. We transmission media, various types of transmission media. Okay, guided transmission media, their characteristics, and unguided transmission media. Okay, conventional guided transmission media in communication, they use twisted pair wires, coaxial cable, and optical fibers. Okay, twisted pair wires is a conventional mode of communication of signals where the wires will be twisted in order to reduce the interference. Okay, they can be used for automation or communication within a building. And coaxial cable, you can see in most of the cable television networks, and most of the now electronic replacing optical fibers. We are going to discuss in detail about what is this guided transmission media and unguided transmission media and their characteristics also. So we'll discuss some of the basic characteristics of this transmission media, guided transmission media. The first one, we'll see about detailed electromagnetic spectrum. Okay, this is the range of frequencies with various applications. Okay, starting from up to visible light. Okay, you can see various communication applications for the various frequency spectrum. Okay, we have the electromagnetic spectrum ranging from extremely low frequency, frequency, ultra high frequency, super high frequency. Accordingly, each frequency band will have some specific applications. Okay, for example, the low frequency will be used for power communication. Okay, the music instruments, they'll be working in this low frequency range only, extremely low frequency, and voice frequency. Voice frequency lies from 300 hertz to 3400 hertz. Okay, up to VHF, we can go for twisted pair wire, and up to ultra high frequency, we can go for coaxial cable. Okay, and amplitude modulated radio, FM radio, and TV and all, they come under this medium frequency to ultra high frequency. And then after ultra high frequency, we have this satellite transmission, microwave transmission. Okay, they come under this unguided medium of transmission. And lasers, guided missiles, they come under the range of 10 power 12, that is terahertz range. So this slide gives a basic electromagnetic spectrum of various frequency ranges and with their corresponding applications. applications. Okay, this is very important. You need to know about the electromagnetic frequencies are allocated for various applications. And the earlier older version of data communication, they were able to write the data in a magnetic tape or an optical disc and able to transfer bulk data. Okay, that was the best idea to transmit the signals. But nowadays we are transmitting signals with the help of wired as well as a wireless medium. This is the slide which gives how twisted pair wire will be. Okay, a twisted pair, two pair of wires will be twisted and they are insulated, and often many twisted pair wires will be bundled into cables. Okay, these twisted pair wires, they have less electromagnetic interference and they can be usually installed in buildings during construction. So twisted pair wire has other lot of categories also. We can see some of the basic categories of twisted pair wire and the applications of twisted pair wire. It is the most common medium used for communication of the signals, and it can be also used for telephone network between the house and the local exchange communication. We use this twisted pair wires, and to communicate within the buildings to private branch exchanges, we use this twisted pair of wires. And even for Ethernet connections, local area network, we use this twisted pair wire. Okay, the advantage of twisted pair wire is it is cost effective, but it is limited to a short distance only, and attenuation will be there. And so in order to overcome the attenuation, we go for amplifiers at repeater places so that we can improve the signal strength. So some of the advantages and disadvantages of twisted pair wire is they're very cost effective, easy to work with, and they can be used for short range communication. But the drawback is it is supports only low data rate. Okay, the data rate is very high in the range of kilobits per second only. We may not be able to support high data rate in the range of gigabits per second. That is a drawback of twisted pair wires. Okay, and there are various categories. We can see twisted pair wires. There are shielded twisted pair wire and unshielded pair wires. Okay, wire is, ordinary telephone wires. We use this wire instead of it is used for data, and it will be very cheaper, easier to install also, but it suffers from electromagnetic interference. Okay, but in shielded twisted pair wire, there will be metal braid or sheathing that reduces the interference, but we need to have the cost we have to bear. It will be more expensive. It is very hard to handle also, because there will be a metal braid or sheathing that covers the twisted pair, which reduces the interference. Okay, and it's not so economical for low rates, but it is a good alternative for high data rate transmission. These are all some of the classifications of twisted pair wire: unshielded twisted pair wire and shielded twisted pair wire. Boys, are you all following? Next, we are going to have, hello, boys?
Yes, sir.
Okay. Next, we are going to see some of the classifications of this twisted pair wire CAT cables, which are used in local area networks. These are all some of the unshielded twisted pair wires categories which are used in local area networks, and their specification also. Okay, Cat3 can support up to 16 megahertz voice communication. Okay, and the twist length will be 7.5 centimeter to 10 centimeter. It is used in old offices. And Cat5 is for data communication. It can support up to 100 megahertz. Okay, it is normally used in office buildings, and twist length can be from 0.6 centimeter to 0.85 centimeter. Okay, and Cat6 6A can support up to 500 megahertz. Okay, and this is 10 gigabits per second Ethernet. So these are all some of the categories of cables which are used in unshielded twisted pair wires. Cat7, Cat7A. Okay, they can support up to 40 gigabits per second. Okay, so when the bandwidth is very high, they are able to support high data rate also. Okay, these are all some of the Ethernet unshielded twisted pair wire classifications. Okay, and next alternative is the coaxial cable. Okay, which are almost used in most of the cable TV networks. Okay, you can see a coaxial cable which has a plastic jacket, and then you have a metallic shield, and then a dielectric insulator, then the central core conductor. Okay, so these types of coaxial cables are used for cable TV networks. Okay, but the cost involved will be very high, and it is very highly protective in nature. It is the most versatile medium, and it is commonly suited for television distribution, long distance telephone transmission. And the advantage of coaxial cable is it can carry 10,000 voice calls simultaneously. And cable internet is also possible with the help of coaxial cable networks. And also it can be used for local area networks. Okay, so coaxial cable finds applications in television broadcasting, long distance telephone, and in internet, but it is very less vulnerable to interference than the twisted pair wire. And due to the concentric structure, the electromagnetic interference will be less. And here also we need to have periodic amplifiers or repeaters in order to increase the signal strength to the desired level. Okay, these are all some of the characteristics of coaxial cable. Next, the very important communication, guided medium of communication is the optical fiber. Okay, optical fiber consists of a core and a cladding. Then the outer is by a polymer overcoat. You have a polymer overcoat which acts as a shield. Okay, and the change in refractive index allows by total internal reflection. The core dia will be in the range of 8 to 100 micrometers. It will be glass fiber or plastic fiber. The glass or plastic coating of fibers, especially, it is designed for lower index of refraction. So due to the change in refractive index in the core and cladding, the signals get transmitted as total internal reflection, and then it will be guided through the optical fiber. Okay, so the outer coat, the plastic layer, is to protect against environmental dangers. So optical fiber communication are able to have large bandwidth, and so it can support high data rate also. Some of the advantages of optical fiber communication is it has greater capacity, and the data rate will be in the range of gigabits per second, and small size, weight also less, and very easy to installation, less physical space needed in ducts. And another important aspect of optical fiber communication is they require less amplifiers. Okay, once in approximately every 50 kilometers only, whereas when you go for conventional cables, twisted pairs, you need to place the repeaters or amplifiers at every 2 kilometers or 3 kilometers. So here the repeaters are not necessary. Only you will place the repeaters at every 50 kilometers. And electromagnetic isolation, there is no interference, no crosstalk, very secure mode of transmission is possible with the help of optical fiber medium communication, which is a most secured guided medium transmission. Okay, and it can support long distance communication lines. Subscriber loops can be easily connected from the most of the telephone exchanges. Now they are replacing by optical fibers, and most suitable for high speed local area networks. If you want to transmit the data at a very high speed, then optical fibers are the choice. Next, we are going to see in detail about the unguided medium of transmission, which is wireless transmission. Okay, for wireless transmission of signals, we need the help of a transducer called as an antenna. Okay, so what is antenna is, antenna will convert the electrical signal to an electromagnetic signal. Okay, these electromagnetic signals are transmitted in free space, and in the receiver it will be converted back to electrical signal. Okay, and in antenna there are different types of antenna. One is directional antenna, other one is omnidirectional antenna. What is directional antenna is, directional antenna can transmit signal in a focused beam, that is in a particular direction only. For this, careful alignment is required, whereas an omnidirectional antenna can spread signals in all directions, that is 360 degree. It can be received by multiple antennas in that location. Okay, so it is type of a broadcast antenna which are used in radio, TV, and all. They use this type of omnidirectional antenna. So in wireless transmission, we need the help of antennas to transmit as well as receive the signal in order to convert electrical signal to electromagnetic signal and vice versa. We'll see some of the frequency range which are used in wireless communication. Okay, so frequency range, which is 1 gigahertz to 40 gigahertz, it is referred to as microwave frequencies. What is microwave frequencies? They have short wavelength. Okay, frequency will be, when the frequency is very high, the wavelength will be very small. Okay, because wavelength is nothing but velocity of light divided by the frequency. Okay, velocity of light 3 into 10 power 8, when you have in the numerator and denominator we have the frequency, the wavelength will be very short. Okay, and so these microwave frequencies are very highly directional. They can be used for point-to-point link as well as satellite link. Okay, and 30 megahertz to 1 gigahertz, they are used for broadcast radio, which is omnidirectional and transmit the broadcast information. Okay, an example of terrestrial microwaves it is given. Okay, so you can see in a tower we can install some parabolic dish. Okay, which helps to receive the focused beam. So it has line of sight transmission, can be used for long haul telecommunications. It can support voice as well as video. Okay, and no long distance cabling is required. No need to buy but frequency band, and it is sensitive to atmospheric conditions but subjected to multipath fading. Okay, these are all some of the features of terrestrial microwaves, but we need to have high towers installed to transmit the signals. Another option for microwaves is to transmit signals by satellite, which acts as a relay station. Okay, the satellite receives on one frequency, amplifies, repeats the signal, and transmits on another frequency. Okay, example, television broadcasting, the satellite TV and all, they require this type of principles only. Applications, television, long distance telephones, and private business networks. Okay, so for this they use uplink frequency and the downlink frequency. What is uplink frequency is the earth station, when they are going to transmit signals to the satellite, it is called as the uplink frequency, and the downlink frequency is the satellite transmitting the signal to the ground station is called as the downlink frequency. So satellite acts as a transponder between the ground station, and it transmits other ground stations with the help of this uplink and downlink frequencies. Next, we are going to discuss the basics of asynchronous and synchronous transmission. Very important. This is the type of communication which will be used in almost all the communication protocols. Okay, what is a communication protocol? Is they agree upon some terms in order to transmit and receive the signals. Okay, so here synchronization is very, very important between the transmitter and receiver. That is, the sender and the receiver, they must cooperate to establish a proper communication, meaning they need to know when to start and when to stop. Okay, and the data rate also should be known to the transmitter and receiver. They should be in common. Okay, so when you say it is a synchronous type of communication, meaning that the transmitter and receiver, they are going to work at the same frequency. Okay, and if the transmitter and receiver are going to operate at different frequency, then it is called as asynchronous type of communication. So there are two main types of communication which are happening in data networks. One is the asynchronous communication and other one is the synchronous communication. Synchronous communication, same clock frequency. Asynchronous communication, different clock frequency, but uses start and stop bits. We are going to see some of the basic characteristics of asynchronous and synchronous communication. So in asynchronous type of transmission, the data is transmitted one character at a time. Basically, each character will have 7 to 8 bits. Okay, and before communication established, okay, what happens is these two parties, transmitter and receiver, they agree on the data rate and they agree on the character length also. Okay, and then only communication can be possible. The parties do not need to agree on starting and stopping time prior to the communication. They exchange starting and stopping bits information, and so no common clock is required in asynchronous type of communication. That is very important in asynchronous communication. There is no need for common clock. The transmitter and receiver, they may operate at different frequencies. This is how the signals are transmitted in asynchronous type of transmission with the help of start and stop bits. Okay, you can see when communication is going to start, you will send the start bit, after start bit is transmitted, then we'll have 5 to 8 data bits, and then parity bits will be added at the end in order to check for error detection. Okay, error detection. At the receiver, when the signal is received, if at all it has any errors, it can request the transmitter to retransmit the signal. So this type of communication is called as asynchronous type of transmission, where it involves start and stop bits for transmitting the signals. So what are the asynchronous transmission behavior? The receiver will look for a transition from high to low, binary 1 to 0 transmission, and then it samples the next character length intervals, then looks for the next 1 to 0 for next character. Okay, and this asynchronous type of transmission will be used for communication in the master slave communication, that is RS-232 communication, RS-485. They use this type of communication. Okay, and the overhead bits are 2 to 3 bits. Okay, parity bits will be used. So these are some control information which will be transmitted in asynchronous mode of transmission. And what is synchronous transmission is the transmitter and the receiver, they will work at the same clock frequency. Okay, and the block of data will be transmitted without any start or stop bits, and there will not be any overhead. Okay, except error detection or correction. And when the clock starts, the data also starts. When the clock stops, data will be stopped. Okay, this is synchronous type of communication. Data is sampled once per clock cycle. No further synchronization needed for short distance and point-to-point communication. Okay, these are all some of the basics of asynchronous mode of communication and synchronous mode of communication. When they are going to work with same clock frequency, synchronous mode of transmission is possible. When the transmitter and receiver are going to operate at different clock frequency, then asynchronous mode of transmission is the alternative. Okay, these are all some of the basics of communication principles which are used for transmitting the signals. So just I want